3.7, 3.8, zeros of polynomial functions. So these are the last two sections of topic 3. And what we talk about in these notes are ways to solve a polynomial equation by using graphing as a technique for solving. But along with that, using the new things that you learned last week, synthetic division, long division, some factoring techniques that you already knew coming into this topic, and also utilizing the multiplicity of a root when you are graphing a function. So we pull it all together in these last two sections. So in the first example, our polynomial is written in factored form. So if we were to expand that and write that x minus 1 squared as x minus 1 times x minus 1 times x plus 2, we would see that the factor x minus 1 shows up twice. That indicates that the zero associated with that factor has a multiplicity of 2. So that's what the word multiplicity means, okay? The multiplicity is the number of times the factor appears as a 0. So our first 0 is going to be x equals 1 with a multiplicity equal to 2. The second 0 is x equals negative 2. So I'm going to go ahead and put a dot at 1 and a dot at negative 2. What is also helpful when graphing polynomials that are where you already know the zeros, because these types of polynomials, we don't have to solve for the zeros. It comes in the form where you can determine the zeros by looking at the factors. The y-intercept is a useful point to know because it helps you when you're graphing. So the y-intercept is where you plug in 0 for x. So that's going to be 0 minus 1 multiplied by 0 minus 1 multiplied by 0 minus 1. So that's going to give me a negative 1. So 0, negative 1 is my y-intercept. I know that the degree of this polynomial is 3, because there's 3 factors there. So if you were multiplying it out, the lead term would be x cubed. And so my parent function, think about the cubic function. It looks like this. Why is that useful? Because that's how we know where to begin the graph. So we're going to start by graphing here, right? And when we hit negative 2, all right, so I made a mistake, and maybe you guys caught it. Over here, this was 0 minus 1. That doesn't make any sense. This should have been 0 plus 2. And so my y-intercept is 2. Now, I knew I made a mistake, and let me tell you why. As I was graphing, and I came up to that negative 2, I knew that I had to go through the x-axis. But if I went through the x-axis, the y-intercept is down at negative 1. Doesn't make any sense. So I'm going to go ahead and remove that. So it was good that I made that mistake because it helps you to see why the y-intercept is a useful point on the graph. So I'm going to go through negative 2. I've got to go up there, right? Now I have to come down to the next x-intercept, which is 1. But at 1, I know what my end behavior of my cubic function looks like. So I'm going to turn at 1 and go back up. That turn at 1 represents a multiplicity of 2. It's also an extrema, because that's one of the turns in the graph. You're turning at 1, or we say you bounce at that 0. All right. For the next one, I'm going to have you put some stuff into Edpuzzle, okay? So let's begin with the zeros, right? So go ahead and list the zeros in the box in Edpuzzle. Just list the numbers separated by commas. All right, so we have x equals 0, x equals -4, and x equals 1. Go ahead now in the box in Edpuzzle and tell me what the multiplicity of this 0 is. X equals 1. What is the multiplicity? All right, so hopefully you put 4 in the box. So that multiplicity is going to give us some information about how we graph when we get to that 0. So we have got one at 0. We have 1, 2, 3, -4. And we have 1. All right, the next thing I would like for you to put in the box is I would like for you to tell me what the degree of this polynomial is. All right, so the degree is 6, because if you were to expand this, this would be x times x plus 4 times x minus 1 times x minus 1 times x minus 1 times x minus 1. And that's why that has a multiplicity of 4. And if you were multiplying this all out, the lead term would be x to the 6. There's 1, 2, 3, 4, 5, 6 x's. That's useful for end behavior, okay? We already have the y-intercept because it's right here at 0, 0. If 0, 0 is an x-intercept, then it's also a y-intercept. All right, we know that the lead coefficient would be positive. All right, so if you were to multiply this all out, there's no negatives in front of any of those x's. And so my polynomial is going to start here. It's going to go through. I don't know how far it's going to go through. Then it's going to come back up. I don't know how far it's going to go up. And then it's going to hit this guy. And then it's going to go back up. Now, if we actually looked at it on Desmos, I have no idea where the extrema are, right? I don't know how low that goes. I don't know where it turns. And I don't know how high it goes in between 0 and 1. If that was a question I was asking you, I would have you put it into Desmos and click on those turning points, and you would be able to tell me what those relative min and relative max are. Okay? All right. So let's talk about using Desmos, synthetic division, and factoring to solve a polynomial. All right. So the first thing is, let's look at this polynomial, and I see terms on both sides. So let's get everything over to one side. All right. So I'm going to subtract everything to the left just because it's easier. So that's going to be -x cubed, subtract 8 minus 3x squared, minus 3x minus 1 equals 0. Let's go to Desmos and pick up a 0, all right? So -x cubed minus 3x squared. So I'm going to open up Desmos. Okay, so -x cubed minus x squared. Okay, let me go back one more time and make sure I've got, minus 3x squared minus 3x minus 1 minus 3x squared minus 3x minus 1. And as we look at the graph, we see that there is a real 0 at -1. That's an integer. So -1. So I know that there is a 0 at x equals -1. But I don't know what the other two zeros are. And so here's where we're going to use synthetic division. So we're going to put -1 in the house. We're going to write down the coefficients, -1, -3, -3, -1. And we're going to do the steps for synthetic division. So bring down the -1, multiply it by the -1 in the house, and you get a +1. Add -2 times -1 is +2. Add -1 times -1 is 1. And of course, we have a remainder of 0 because you always have a remainder of 0 when you know that the number in the house is in fact a 0. All right, so -x squared minus 2x minus 1 equals 0. You can factor, you can quadratic formula. right? When you're solving quadratics. We already know that this doesn't factor because we looked at the graph. And on the graph, the polynomial does not cross the x-axis any more than at that one point. So we can't have any more real zeros. So I'm going to go straight to quad formula. All right, so x equals the opposite of b plus or minus the square root of b squared, so that's 4, minus 4 times -1 times -1, all over 2 times -1. So let me just check that. Opposite of b plus or minus b squared minus 4 times -1 times -1, all over 2. So that's going to be x equals 2 plus or minus the square root of 4 subtract 4. All right, but if you go to solve this, you see that you get x equals -1. So while you were thinking that there were two non-real, it turns out that when you solve, -1 is in fact the only root. Well, that would mean that the equation of this polynomial is f of x equals x plus 1 cubed. There are no other ones. And so is that the case? If you multiply x plus 1 times x plus 1 times x plus 1, do you get this polynomial up here? And if I multiply through that by a -1, I'm going to get x cubed plus 3x squared plus 3x plus 1. Let's check it out. And that's why I had you practice multiplying. So that's going to be x squared plus 2x plus 1 times x plus 1. And that's going to be x cubed plus x squared plus 2x squared plus 2x plus x plus 1. And if you combine like terms, you get x cubed plus 3x squared plus 3x plus 1. So there was the process where we would use synthetic division, and then we know that there are 3 zeros because it's a cubic. But the way you answer this is x equals -1 with a multiplicity equal to 3. Now let's go back and look at that graph before we move on. A multiplicity that is odd means your polynomial cuts through the x-axis, and that's exactly what this one does. Okay. Let's go back. So that one was a little tricky because when we solved with the quadratic formula, we ended up back where we started, and so we had to interpret our results. It won't always happen, but in this case it did. All right, find all the roots and zeros. Again, x cubed minus 2x squared plus 5x minus 10. Let's see if it factors. Whenever you have 4 terms, it's always okay to begin by factoring. All right, so GCF, x squared, x minus 2, GCF 5, x minus 2. GCF x minus 2, x squared plus 5 equals 0. Solve. X minus 2 equals 0. X equals 2. X squared plus 5 equals 0. X squared equals -5. X equals plus or minus root -5. X equals plus or minus I root 5. So if we were to graph this, let's do it. And let's talk about how what we just did supports that. So x cubed minus 2x squared, whoops. All right, so let's see, did I get that right? X cubed minus 2x squared plus 5x minus 10. So let's take a look at this polynomial. Again, there is only one 0 at x equals 2. However, where are the other two zeros? Is this one like the previous example where there's only one real 0 but it has a multiplicity of 3? Well, that is not the case because as we showed here, we solved and we have one real, two non-real. So one real, two non-real. All right, the next one has several terms. 1, 2, 3, 1, 2, 3, 4, 5. So again, let's put this into Desmos and see if we can find a 0. So x to the 5th plus x cubed. X to the 5th plus x cubed plus 2x squared minus 12x plus 8. 2x squared minus 12x plus 8. All right, so first thing I'm going to write here is graph on Desmos to determine a 0. So on Desmos, I can see that there is a 0 at -2 and there is a 0 at 1. Now, not only is there a 0 at -2 and at 1, but at 1, we see that the polynomial comes down, it touches 1, and then it turns. So that means at 1, there is a multiplicity that is even. It could be 2, it could be 4. Now, if the multiplicity of that 0 was 4, we would be done. Because if the multiplicity is 4 and then there's another 0 at -2, that's a degree of 5, and we already know that it is a polynomial with a degree of 5. But we don't know that until we try. So we're going to come back and we're going to use our zeros at -2 and 1, so again showing you -2 and 1, to reduce the polynomial, okay? So we're going to put -2 in the house, 1, x to the 5th has a coefficient of 1. X to the 4th is not in this polynomial, so we're going to hold a place. So 0x to the 4th, or actually you could just put 0. It might look confusing if you put 0 and x in there. 1, 2, -12, and 8. Draw your line. 1, -2, -2, 4, 5, -10, -8, 16, 4, -8, 0. And again, as you work through synthetic division, you have to get a 0 at the end. The remainder is 0 because -2 is a 0. All right? Now, I do it again with the next 0. So I put 1 in the house, and then I use the same numbers. Let me move that down just a little. So I put 1 in the house, and I use 1, -2, 5, -8, and 4. Because if it's a 0 of the original polynomial, it will be a 0 of any polynomials you get in synthetic division. So bring down the 1. 1 times 1 is 1, -1, -1, 4, 4, -4, -4, 0. Now, when you're looking at that, you might think, okay, what is that? So the original polynomial was x to the 5th. That means this is x to the 4th. That means this is x to the 3rd. So the polynomial that remains is always one less degree than the original. So now I have x cubed minus x squared plus 4x minus 4 equals 0. And I need to solve that. And I can't throw it in the graph because I'm looking at the original graph and I know that there's only real zeros at -2 and 1. And so I'm going to use factoring techniques. Again, factor by grouping. So x squared, x minus 1, plus 4, x minus 1. So x squared plus 4, x minus 1 equals 0. Well, we already knew that x equals 1 was a 0. because we just used it in synthetic division, but it is a 0 with a multiplicity of 2. So I'm going to come back over here and go like this and say multiplicity is equal to 2. What do we do with the x squared plus 4? We solve it. X squared plus 4 equals 0. X squared equals -4. X equals plus or minus the square root of -4, which is plus or minus 2i. And so x equals plus or minus 2i. Now I want you to notice that those are complex zeros, and they're coming in pairs. Positive 2i, negative 2i. And that completes the 5 zeros. So there's a 0 at -2. There's a 0 at 1 with a multiplicity of 2. That means 3 zeros. And then 2 more that are non-real. There's 5, and the degree of this polynomial is 5. Now we're going to use that idea that those non-real zeros come in pairs when we write the equations of polynomials. So write a quadratic function, p of x, with rational coefficients in standard form such that p of x equals 0 and has 2 plus 5i as a root. So if 2 plus 5i is a root, then 2 minus 5i is a root, because they come in conjugate pairs. And we used the conjugate last semester when we were dividing with complex numbers. So 2 plus 5 and 2 minus 5i will be the zeros of this quadratic. Remember, quadratic, degree of 2. So if 2 plus 5i is a root, then x minus 2 plus 5i is a factor. And x minus 2 minus 5i is a factor. So if you know the zeros, you can write the factors. What have we been doing? We've been taking the factors and writing the zeros. But now we're going to take the zeros and write the factors. Now that looks pretty darn complicated, right? So let's do some rearranging. So here, I'm going to write this as x minus 2 minus 5i. Okay? And then I'm going to write this as x minus 2. Well, minus a minus is going to be plus 5i. So this is manipulating the terms. So I'm distributing that subtraction. So x minus 2 minus 5i. But I'm grouping the x minus 2. X minus 2 plus 5i. Why? It really makes the rest of the multiplying more simple. So we're going to multiply this times this. That's going to give me x minus 2 squared. Plus, now I'm going to multiply this times this. 5i times x minus 2. Notice I'm not multiplying it out yet. Then I'm going to multiply this times this. Minus 5i times x minus 2. And then I'm going to multiply negative 5i times positive 5i, which is 25i squared. So it looked super complicated, but I think here, plus 5i times x minus 2, minus 5i times x minus 2, those are going to drop out right away. X minus 2 squared is x minus 2 times x minus 2. That gives me x squared plus 4x plus 4, because you're going to get, no, minus 2x, sorry. Minus, because you're going to get x minus 2x, that's your minus 4x plus 4. Plus, and then that 25i squared is 25 times negative 1. And so my polynomial is going to be x squared minus 4x plus minus 21. And what was the name of it? P of x. And so that's what this topic is on. It's on writing quadratic functions given the zeros. There's a lot of multiplying and manipulation with variables here. That's why I had you practice it. All right. A polynomial function has degree 4 and has zeros 3 minus 7i and 4i. What is the polynomial equation in standard form with these zeros and roots? Okay, so it's q of x. And if it has a degree of 4, there will be 4 zeros. There's 1 and 1. So if 3 minus root 7 is a 0, then 3 plus root 7 is a 0. And if 4i is a 0, then minus 4i is a 0. They come in pairs. Irrationals come in pairs. Think about solving a quadratic formula. When you write the solution, you write it as a plus or minus b square root c, right? And the same thing for complex, a plus or minus bi. So building it is a challenge. So x minus the 0. X minus the 0. X minus the 0. X minus the 0. So just take a look here. Here's your 0. Here's your 0. Here's your 0. Here's your 0. So there's your 4 zeros. And we've got to multiply this all out. All right. Again, I'm going to rearrange for this one. So that's going to be x minus 3 plus root 7. So in other words, I distributed that negative into the parentheses and regrouped. So x minus 3 and then plus, because minus a minus. And then again, x minus 3 minus root 7. X minus 4i. And then x plus 4i. Now I'm going to leave those two alone and just take care of these. So this is exactly what I just did before. So this times this. That's going to be x minus 3 squared. And then minus root 7 times x minus 3. And then plus root 7 times x minus 3. And then minus root 49. And look, these guys are going to drop out. You're going to square that binomial, x minus 3 times x minus 3. That's going to give you x squared minus 6x plus 9 minus 7. And so that gives you x squared minus 6x plus 2. Now you're going to multiply x minus 4i times x plus 4i. So that gives you x squared. And then again, you would have minus 4ix plus 4ix minus 16i squared. So again, those drop out. And you're left with x squared plus 16. Now, again, you can do the box. You can do whatever is easiest for you. I'm going to do the box. So x squared minus 6x2 and x squared 16. So you can see how you're getting a degree of 4. X to the 4th minus 6x cubed plus 2x squared. Whoops, I don't really need the plus there, guys. 16x squared minus 96x, and then 32. So let's write it all down. I believe we called the polynomial q of x. So that's x to the 4th minus 6x cubed plus 18x squared minus 96x plus 32. All right, so take a look at that problem. It's quite extensive, but a lot of what it is manipulating the terms here so that we have an easy way to multiply. So the idea here, and I'll put a little star by it, is that you regroup. All right. So for the next one, we have zeros, 2 minus root 3, and 5i. So that means we're going to have a 0 at 2 plus root 3 and a 0 at negative 5i. So this one is just like the one we did. So if you want, pause and see if you can at least write your polynomial the way I did in the other one, or you can just continue to watch. All right, so polynomial function Q, that's going to be x minus the 0, x minus the other 0. Doesn't matter which order you write them in. X minus the 0, x minus the 0. So hopefully I've said that enough. If you know what the 0 is, to write the factor, it's x minus the 0. And now here's that important part where you regroup. So that's going to be x minus 2 minus root 3, and then x minus 2 plus root 3. And then, of course, you have x minus 5i and x plus 5i. Okay, now we're going to just do our normal FOIL here. So that's going to be x minus 2 squared, and then it's going to be plus root 3, x minus 2, minus root 3, x minus 2, minus root 9. That's going to be x squared minus 4x plus 4. These guys are going to drop out, minus 3. And so that's going to give me x squared minus 4x plus 1. Down here, if you're going to multiply it all out, you're going to get x squared plus x5i minus x5i. You know those are going to drop out, minus 25i squared. And so that gives me x squared plus 25. And now we're just like we were on the other one. And so I am going to let you, I'm just going to pause for a minute and let you attempt to get the right answer. And then in the Edpuzzle box, I want you to tell me if your answer matches my answer. And so just say, yes, I got it right. No, I didn't. Okay. So this is doing it where you don't make the box, you just distribute, collect like terms. Now when I don't do the box, I always check my work. X to the 4th, 25x squared, minus 4x cubed, minus 100x, plus x squared plus 25, x to the 4th, minus 4x cubed, plus 26x squared minus 100x plus 25. And that is it. And hopefully you got